All right. Good morning, folks. Welcome back from the break. My name is Bruce McDougall. I work for Cisco, and
I'm Zia. I also work for Cisco.
So we're kind of, this is going to be kind of a fairly networky presentation, actually. The question was asked earlier, how many folks are familiar with network technologies? Kind of the next question for this one is, how many folks here are familiar or comfortable with traffic engineering or segment routing? A couple, okay. There's going to be, like I said, a bunch of networking in this presentation, but also some network service mesh as well, and even a demo. So in our agenda today, we're going to basically roll through a bunch of pieces to this presentation. First of all, network service mesh itself basically its problem statement is the network is a black box to cloud native applications. And our problem statement is we're going to go one step further and say that traffic engineering is a part of that network black box. Ed likes to use story time in his presentations. We have brief story time. Telemedicine going cloud native is basically kind of a narrative vehicle for us to build our story around. And then we have a project that we've been working on. It's an SDN kind of traffic engineering proof of concept. And it used to be called Project Voltron, but that's trademarked. So for this presentation, it's called Project Jalapeno. So if either of us says Voltron, it's because we're practiced at saying Voltron, and it's now Jalapeno, so you can remind us of that. Finally, we're going to talk about the NSM and Jalapeno architecture. It's a quality of experience network service and a demo. So the traffic engineering network black box, and I think this diagram could probably be represented in all sort of application environments where there is a network involved. And there's a lot of network engineering diagrams that show this where there's some sort of monolithic SDN controller. And the application signals for help, something magical happens, and maybe the network did something on behalf of the application, we don't know. We're actually going to look to change that. And using our vehicle, basically telemedicine as a potential series of applications where traffic engineering is potentially relevant. So in telemedicine, let's say our narrative story here is we have Maggie, who is a surgeon who is Sarah's sister, and Sarah has built a bunch of Sarah and her company built cloud native applications in aid of telemedicine. And we want to be able to provide services, say we've got specialists that are in the city, but to be able to provide services to remote clinics and the like. So within this kind of application space, if it's all gone cloud native or headed in that direction, you've got a number of applications that are latency and loss sensitive, and other applications that simply are not. So obviously remote surgery is going to be latency and loss sensitive. Whereas, if you're actually engaged in, say, a remote surgery type of application, there's probably a number of video and other kind of AR feeds and things like that that are really data intensive. To get to the specialist, those have to be latency and loss. They have to take the best path. But let's say you're just there's also in parallel replication of all those feeds to the central data center. That stuff does not have to be latency and loss sensitive. So we divide the world up into two traffic classes for this. There's traffic that is latency and loss sensitive, and it's really important. And there's traffic that simply is not. And this is actually kind of a lesson learned from some of the cloud operators that we work with in our day job, essentially, is cloud operators they do a lot of SDN traffic engineering, but the way they kind of do it is they divide the world into sort of traffic that we really, really care about and traffic that we care a little bit less about. They care about all traffic. So we have an example network here. It's a network that maybe has like geographic scope, could be nationwide. There's also metro area networks attached to it. There could be central data centers as well. And then we have a patient and a specialist. And a Kubernetes or a cloud native set of applications that are driving this kind of medical experience. So there is the remote surgery aspect, but there's also monitoring and other bits to this. And so what we're going to do is we're going to actually show that for certain parts of this use case, pieces of it need to have the lowest latency path. Other pieces of it, though, can actually be distributed across the least utilized path. So we want to, let's say if we're the network owner here, if it's a hospital system that owns this network, they want to get the most out of their out of their links that they've provisioned, even the ones that are underutilized. Or if it's a service provider network, the same goes, essentially, to be able to provide the critical traffic, the low latency, or the best path. And then to be able to take traffic that doesn't need that, to be able to distribute it evenly and get the greatest utilization of the network they can. So Project Jalapeno. Project Jalapeno kind of tries to rethink SDN, at least in the way that network vendors such as ourselves have been talking about SDN for several years now. So we took a step back. We said we actually want to give applications the ability to choose directly their service or their SLA, i.e. path expressed through the network. We also contend that SDN is not about controllers and protocols, but SDN is actually about databases and APIs. APIs are far more agile than waiting for an industry to come together around a protocol. And the controller itself is actually just kind of the last step in the picture. If you're really doing SDN, there's a whole lot of data analysis and policy that has to happen first before the controller comes into play. We want to eliminate the network black box. So part of that is we're going to perform our tunnel encapsulation. When we're doing traffic engineering, generally we're sticking labels, segment-routed labels, MPLS labels, or maybe some other encapsulation on the packets outbound. We're going to do that at the host rather than at, say, the first hop router. This gives us the most flexibility. It's also very cloud native. We've got VPP doing it. We want to expose path attributes, our traffic engineering attributes, via API, and we want them to be very easily understood. So a application owner can make this program in this request, essentially, and it's in plain language that is easy to understand. In a lot of these SDN presentations amongst network vendors, there's a monolithic controller. Our thing, we don't even call it a controller. It's really a Kubernetes application that's got a whole bunch of little containers that are all doing their own part. And for best results, we want to also combine both network and application performance data whenever possible. Right now, our system uses segment routing labels, but we're going to pivot and hopefully be using SRv6 as soon as possible. I'm going to whip through this. This is kind of like the architecture of our system itself. Say you've got, essentially, if you want to build an SDN stack and do traffic engineering, you need a data collection and analysis stack. Ours is essentially kind of, it's mostly open source pieces. Collectors and Kafka to aggregate. We've got a time series database. And ultimately, our system, we would hope to be able to plug it directly into kind of anybody's data collection stack. It's decoupled from the data collection stack. And so the pieces of Jalapeno are actually, here's the microservice pieces, where there's a number of data handlers that are grabbing data off the bus, and they're feeding it into some virtual topology databases, essentially. And so these virtual topology databases are mapped to, or kind of aligned with services. So you've got a series of microservices that are mining the database and then kind of taking data out of it and putting it back into kind of an expression that is a virtual topology. So a virtual topology could be a VPN. It could be something like the low latency graph or something like that. And essentially the way this is built, because these services are, they're just, you just add a container essentially. So it's highly extensible. You can just build, if you come up with a new app or service or virtual topology, you just build a new container, mine the data, and put it back in. And then we expose everything via an API gateway. So in this case, now the application makes an API call, and the Jalapeno system itself responds back with a segment routing label stack that corresponds to the request or the service or the SLA that was requested. And then that label stack, if you understand, or if you do segment routing or kind of MPLS traffic engineering, that label stack itself, when it appears on outbound packets, essentially becomes the engineered path. Like the policy is expressed in the data plane itself as it processes the labeled packets. So NSM with Jalapeno, equality of experience network service. A quick bit of NSM context, did a little screen grab here. On the far left, we've got the network service client. We also have a network service client. It makes a request of NSMD. NSMD spins up, or at least a network service endpoint gets spun up and responds back that here's the endpoint, here's the pieces to get connected to me, and then network service mesh builds the cross-connect between the two. We're basically doing the same thing, but kind of adding a step, essentially. So we've got a network service client on the far left, and on the right, we have a transport network that could be a national or a metro network, something like that. And our environment is all contained inside of, at least in our demo environment, contained inside an Ubuntu server. So our client's going to make its network service request for a quality of experience service. NSMD is going to create the network service endpoint and cross-connect it to the client. Then the network service endpoint itself is going to make a API call to Jalapeno. And it's going to get a label stack response back, and the NSE is then going to program essentially a labeled route on itself. It's either, if we're using Linux IO, it's an IP route command in Ubuntu, or if it's we're using VPP, so it's an in-cap with MPLS and VPP. And then when the client goes to send traffic to the destination, leaving the client, it's IP packets. But then coming out of the NSE, it's going to be labeled packets on the way to the destination. So that's basically the architecture and the setup. And I'll turn it over to Zia for demo.
Cool. Hello. So yeah, just if we lost you along the way, basically with NSM, right, the goal is to reduce the complexity around having these advanced networking features in your cloud-native environment, right? That's that NSM. And with Jalapeno, the goal is to reduce the complexity around application developers seeing value in the network. So it's kind of like a perfect fit in that way. And that's because with default routing, right now, if you're using best effort routing from your client to your destination, there's a good chance, hey, it's fine, it's going to pick a path that's probably going to go, let's say, over R0, R1, out R71, right? And that's fine. Now, recently, not recently, but there's been advancement, and we have the capability to now understand what's going on in the network. So we have the ability to measure the health of the network in terms of latency, congestion, using things like telemetry and stuff, right? So now we actually have this understanding that, hey, this path between R1 and R71 is maybe not the best in the network right now. There's a couple other paths that are maybe a little bit better. And as Bruce was saying, we have two traffic classes, traffic we care about, and traffic we care about, and traffic we care about a little bit less, right? So you want that traffic to go over the other better paths. However, with the default routing, there's a good chance it won't react to the fact that we have this understanding of the network now. And that's kind of what we were saying is, hey, how do we get this reaction to happen given the health of the network at the time, right? And so then we incorporated things like segment routing labels, and we built out this Jalapeno infrastructure and the services behind it that kind of married this topology and performance data together, all right? And it says, okay, now we have an understanding of the network at this instantaneous moment, or given averages in the past, and we understand that that path is potentially not the best path anymore, right? And if we have something that we want to do, then we can send, if it's super sensitive, we can send it over a different path instead. So that's the idea behind what Jalapeno is doing. Now, how do we integrate that with network service mesh, right? A lot of you guys, I'm sure, have seen these YAML files before. This is kind of just like an idea of how simple it is to use network service mesh, right? You just build out these YAML files, and you specify the images of what services you want to deploy, and you're good to go. So on the left, you can see that we have the network service client, which is the just spins up a quality of experience or service. Network service client saying, hey, build the cross connects out to the endpoint where the actual logic is going to be. At the endpoint, you can see midway down, there's actually environment variables that we're setting that implies what we kind of want from our Jalapeno project. So midway down, you'll see that we have a destination specified, and we've also specified what type of request it is. In this case, it's going to be latency. So with that being said, I'm going to actually switch over to the demo. First and foremost, I'll show you guys how we're kind of deploying it. These are all our infrastructure components and our services running in Kubernetes. And then we've also eventually pulled all of that data together and married it with our services into ArangoDB. So stored in these guys, whoa, I'm not sharing. One sec. Better? Sweet. Okay, cool. Yeah. So in this, you can see that we got a bunch of these collections, right? And some of them are topology-oriented collections, like saying who am I connected to, what do I got? And some of them are more service-oriented collections that have metrics and performances behind them. And then finally, we've also got the typical Grafana and stuff like that, ability to kind of graph out what you got going. So now to the demo. the wrong one. Okay. So right now, currently in our environment, I have set up some latency, right? And I'm going to go ahead and manipulate this. This is some synthetic latency that we've got going on right now. So all 4 paths that we have the same kind of 10 millisecond delay, right? I'm going to get our latency service running. So this latency service right here is just one of the services we made as part of Jalapeno that kind of just calculates the paths out and then sends pings out, measures the latency, and then upgrades uploads that into our Orango DB collections, right? And kind of informs the API. So that's running there. What I'm going to do now is I'm going to change these latencies so they're distinctive, right? And they have different values. So we're going to say, hey, let's give you maybe 20 milliseconds. Let's give you maybe 30 milliseconds. And let's give this guy right here maybe 40 milliseconds, right? And make it distinctive in terms of what the best path would be, right? And let's list those delays. Boom, right? So what's happening right now behind the scenes is, again, that latency service is running and calculating and understanding what's happening in the network because of the things I just did, right? So what effectively should happen, right, is that we should be able to start up one of our clients, right? And it should enforce a path, right? And that path should be representative of the best path in the network at the time. So let's verify that by hopping over to this guy and taking a look at what we got. So it's still kind of uploading those latencies coming into this system. But the point is, it's definitely not going to be taking one of these paths that has a worse latency than the current best path, right, that we've enforced. So let's verify that. Yeah. So right now it's going over this path 100,001. That's a segment routing label, but again, could be anything. 100,001 and 24,003, right? And if we come back here and confirm that that is the lowest one, we can see it is. That's the one with latency being 10 milliseconds versus 20 or 30 or 40, right? So that's the idea behind it. Now, if we've switched over to the NSM context, right now I'm running this, the quality of experience NSM endpoint, right? So I've got the system set up where it's measuring performance and topology. It's marrying them. I have access via API. Now I want to enforce that via an endpoint, right? And that's what we're doing right now. This guy's actually going to be going ahead and actually communicating with the API behind the scenes and saying, hey, give me the lowest latency path to this destination and give me the label stack to be enforced there. And as you can see, it is encapsulating it there via MPLS. And that is right there. So that's the idea behind the demo. We have this Jalapeno project going on that provides this API to say, hey, I want my traffic to have the best treatment through the network, and then NSM has the capability to interact with that, and then you've got this quality of experience network service. Yeah. Oh.
Go back to the PowerPoint.
Yeah, totally.
All right, so that's most of the presentation right there. Essentially, kind of to summarize, network service mesh is we discovered a few months ago and started playing around with it and realized that it was actually a really good, or our proof of concept we've been working on would be a really good complement to network service mesh. Advanced networking features like traffic engineering is not something that a developer or application owner is going to actually want to try to dig into probably. So if we can provide that capability via simple API, via network service mesh, we feel that there's nice value there. So we kind of felt that Jalapeno is a natural fit for NSM sort of traffic engineering or quality of experience network service. And with that said, does anyone have any questions? Yes, sir?
Thanks. So what actually NSM gives you? I mean, could you have done this project based on Motus, for example? I mean, because we get these questions all the time, and you kind of applied it in practice. So
we actually got started on this project without NSM and just made it essentially something where an application could make the API request directly and simply get a label stack pushed down to it. We've got a little Python client that can run on, on a VM or something that can make the request, and then it creates the IP route with labels. So, that in kind of a standalone silo is nice, but then we saw network service mesh is building essentially an ecosystem of capability. And we hadn't done any work with like a CNI or anything yet. So this is great because it means we don't have to necessarily go and integrate with a CNI.
Have you checked the inter-domain feature that we have merged like a couple of months ago? Do you know what that is? Essentially, the capabilities to cross-connect clusters.
No, we'll have to look into it, because that would be really cool.
Yeah.
In a way, the solution that we've worked on, it could, if we were to actually dig deeper into network service mesh, we don't necessarily, to do what we're doing, we don't necessarily need to cross-connect to a network service endpoint, because our network service endpoint is actually VPP. And so under the hood, we could actually, instead of cross-connecting, just push the label stack to that first VPP that's connected to the network service client. But that's something that's, if we decide to go that route, I think we'll consult with Ed and team on if that's a viable thing, or if, because it would involve changing network service mesh code itself, or if the preference would be to keep it architecturally clean and just have that cross-connect to an endpoint itself that then performs the TE.
Yeah, at least if you ask me, I prefer to keep the services on top of, running in containers, not part of the infrastructure. So
yeah, decoupled.
Yeah, that's okay. Okay.
Understood. Yeah.
Okay, thanks.
Yeah, thank you. Any other questions? All right, well, thank you all. Thanks for listening to us.
Thanks.